This is video number 2 for chapter 5. It goes over a couple things that we do in section 5.1, but also a few other kind of random topics thrown in to help us wrap up 5.1. So we're going to be using the DRT formula. I call it the DRT formula, distance, rate, and time, to solve problems. And then we're also going to find unit rates and compare rates and pick which might be a better buy when you're shopping. So make sure you write those targets down on your paper, and also that it goes with section 5.1. So, DRT, DRT. First of all, there's a triangle on your paper. If you fill this in, it goes like that. So, D stands for distance. R stands for rate. And T stands for time. So, please also write down, if I'm looking for the distance, I'm going to be asking, how far did I go? If I'm looking for the rate, I'm asking, or I want to know, how fast did I go? And if I'm looking for the time, then I want to know, how long did it take? Okay, so that should all be on your paper. And now we're going to write the formula for each one. So looking at my triangle here, if I want to find the distance, then I look and I see that R and T are right next to each other. And when things are right next to each other, we multiply. So the formula for distance is to multiply the rate times the time. So rate times time is how I find the distance. For the rate, if I want to get the rate, it's right here. You can see that I have distance divided by, or over, time. So distance divided by time will give me the rate, how fast I'm going. And then for time, well, if I look back over here, let me pick another color so we can see it. If I want to find the time, here's time, then I'm going to do distance divided by the rate. So time is equal to the distance divided by the rate. So for each one, you should have what it stands for, what question we'd be asking, so what are your clues in a word problem, and then what's the formula for each one. Okay, here's a quick example. So DRT, here we go. Make my pen smaller. You bike 28 miles in 3 hours. Well, let's label this. 28 miles, that would be a distance. 3 hours, that would be a time. If I know distance and time, I'm probably trying to figure out how fast was I going. So write that down. That means we want to find the rate. So if I copy the formula, rate is equal to distance divided by time. My distance was 28 miles. Time was 3 hours. And I get 28 divided by 3, 2.66 repeating, and I keep my label of, right here, miles per hour. So that's how fast I was going. What about the next one? Chevy walks at a rate of 3.5 miles per hour. Well, they give me a clue here. This is a rate. We go for a 45-minute walk, and this would be a time. The only trouble with this one is I have to look at my units for a second. I'm measuring my rate in miles per hour, but then I'm giving the time in minutes. So I'm going to have to change one of those. I can't do the problem with 2 different units of time. So let's convert this. 45 minutes out of an hour, out of 60 minutes, that would simplify to, well, if I divide them both by 15, I get 3/4 of an hour. So let's use 3/4 of an hour as my time, then everything will match. Okay, so if I have rate and I have time, I must be looking for the distance. How far did we go? And distance is equal to rate times time. My rate is 3.5 miles per hour. Make sure you write the label with it. My time is 3/4 of an hour. And when I actually multiply those, I get that, and I would label it for how far. Miles, that's how far I went. Okay, let's try one more. I swim 1 mile per hour in the pool. Well, miles per hour, that's giving me a rate, how fast I swim. I try to swim 0.65 miles each day. Well, 0.65 miles, that would be the distance that I try to go. So if I know rate and I know distance, I'm going to be looking for the time. How long does it take me? And time formula is distance over rate. Okay, let's check our units. Are we okay? Miles per hour, miles, good. So the distance, the rate, divide those. Okay, and then let's think about the units on our answer. When I'm looking for time, looks like I was going with hours here when I talk about time. So this would be hours, but nobody goes around saying 0.65 hours to do something. So let's take 0.65 out of 60 minutes and see what that gives us. So I got 39 minutes. So we'll do a lot more practice with DRT in class, but I wanted to move on to this topic of a better buy. So when I say better buy, I mean pick the cheaper option. Like when you go to the store and there's 2 boxes of Cheerio-like cereal, you want to compare them. There's the Meyer brand and the off-brand, or, a Kellogg brand or something, and you want to compare which is the cheaper option. So this is how you do it. For a better buy, you're always, always, always going to set it up as money, so the price or the cost, divided by the items that you're buying. So whatever you're getting, maybe it's the price per pound or the price per ounce or the price per package or the price per can, but always set it up that way with money on top. So I have 2 options here. You're going to buy some CDs for gifts for Christmas. You can either go shopping here at Music City where they have a deal going on. You can get 5 CDs for $49.95. Or here at this store at CD World where you can get 7 CDs for $65.80. So if you're in the market to buy some CDs, where should you go? Well, if I find the better buy, so if I find money divided by items, I'd set it up and find the price per CD at each store and then pick the cheaper one. So at this first store, it's $49.95 for 5 CDs. Notice that I labeled it with a $sign and I labeled CDs. At the other store, it is $65.80 for 7 CDs. So now all we have to do is actually divide them. So divide them both in your calculator and write that down and we'll check it. So these are the numbers I get, but I need to label them. When I divide it over here at Music City, I should label this as $9.99 per CD. So you can either write per or draw the slash. And over here, I got $9.4 per CD. But nobody would write money like that, so I should probably add a 0 there, $9.40 per CD. So when you compare them, you can see that they're cheaper here. They're, 55 cents cheaper if I go to CD World. So that's what it means to pick a better buy, pick the cheaper option. So there, just want to talk for a second about money. When you get money on your calculator, we need to know what it means. So if I'm doing a problem in dollars and I get this, I might also say that that is 3 cents. But I can label it with a $sign or a cent sign, but I have to write it the right way. Or if this is dollars, what does that actually mean? Well, in money, that would actually mean 0.5 cents, half of a cent, right? Or $1.76. I could also say, nobody probably would, but that's 176 cents. Or 85 cents. I could write it like this. Just have to keep them straight and use the right label. 0.2. Well, nobody would write it like that. We'd probably see it with a 0 on there. 20 cents or 20 cents. And this one. Again, you're not going to see money that has 3 decimal points, but if you did, this would mean 7.4 cents. That's what it means. So just keep that in mind as you work on any problems that have money with them. Okay, I'll do one more example and then you've got a couple to practice. So which is a better buy? 5 calculators for 105 or 24 calculators for 552? For all of these problems, you cannot just look at them and guess or look at them and tell. You need to actually work out both options and then pick which one is cheaper. Remember, we always want to do money over items. So I got to write them both down. First option, 105, label it for 5 calculators. Or, and I'll see what that gives me, or 552 for 24 calculators. So take a second to divide both those in your calculator and label them. So here's what I got. The first one would come out to $21 per calculator. Second option, $23 per calculator. So this one's obviously cheaper. All right, so you have 3 more examples that you need to try. You have to write both options down, divide them, label them, and then pick which one is cheaper. So pause and then we'll come back and check. Okay, so I set each one up and then I divided. Make sure you label everything. Every number I wrote down either has a $ or it's labeled pieces or ounces. And then my answers have labels. So this comes out to about 16 cents a piece. And this one is also 16 cents a piece. When that happens, you need to look at more decimal places. Keep going on your calculator and actually look at the next numbers to tell. They're not exactly the same. This next digit would be a 0. This one is a 0 and then a 5. So that one's actually a bigger number, more expensive. This would be my cheaper option. Okay? And then in the next one, well, 128 per ounce is cheaper than 130 per ounce, or 22.2 cents per ounce is better than 24 cents per ounce. Okay, so we want to be able to compare not only prices, but also regular rates. If I have rates in a problem, I need to be able to pick who's faster, who makes more money, whatever the problem is. So here's the problem. You do 33 homework problems in 7 minutes, and Chevy does 42 homework problems in 9 minutes. So who does their homework at a faster rate? Well, I need to find the rate for both people, well, you and Chevy, and then compare them and see who is faster. So I want you to pause it here. This one's really important that you write it down so that we can really talk about it together. So pause, write down the rate for each person, and then decide who's faster. Okay, before you just copy everything that you see down on your paper, I want to talk about what these numbers mean. So most people probably found how many questions can I do in a minute. You probably set your rates up like this, right? 33 questions in 7 minutes, 42 questions in 9 minutes, and divided. Well, when you divide, you need to label your answer. So this is homework problems per minute. Homework problems per minute. Okay? Now let's pick who's faster. Well, you got to think through what the units mean. I want to do more homework problems in a minute if I'm faster. So this person, which happens to be you are faster. Okay? But maybe you thought about it and said, well, let me see how long it takes me to do each problem. Let me find minutes per problem. And minutes divided by problems, minutes divided by problems, and find that rate. So you divided it kind of the other way and got these numbers. Well, what do they mean now? This top one means it takes you 0.212 minutes per problem. And in the second one, it takes you 0.214 minutes per problem. So now if I want to compare these, I have to think through again, what did I find? And which one actually is going faster? Well, if you're going faster, would it take you more minutes to complete each problem or fewer minutes to complete each problem? Yeah, in this case, faster means less time for each problem. So this person, the smaller number, is going faster. Whatever answer you get, they should match. Either way you do it, you should get that you, the one who does 33 problems in 7 minutes, is faster. Okay? But I just want to show you that even if you change the way you set up your rate, you have to think it through. What does this number mean? What does this number mean? And check them together to decide which one is actually going faster. We don't have a lot of time left, but in this video I just wanted to mention, whenever you ask yourself, hey, how many times does this number fit into that number? Or how many times does 8 go into 652? Or how many times does it take 27 to make 10,043? Anytime you ask yourself that question, you divide on your calculator to get the answer. So, really quickly, how many times does 8 go into 652? Well, I would type this into my calculator and get the answer. Go ahead and write it down. Or how many times does 27 fit into 10,043? Well, 10,043 divided by 27 will give me that answer. So it's just important that you know anytime you're saying how many of these does it take to make that number, or how many times does this fit into that, you're going to divide it on your calculator. So check your answers with mine. This is just an idea we're going to be using a lot in this chapter. And it goes along with charts like this. So I'm going to let you try them, see if you can find all the blanks. right? Use the numbers they give you to see if you can fill in all the missing ones. I'm going to pause here, let you try it, and then I'll show you the answers, but we'll do a lot more of this together. So check